My name is Raj Korpan. I'm in the computer science department. I teach several computer science courses. One of them is the senior capstone course, which I absolutely love teaching. It is the final culminating course for seniors in the CS department. And they have to work in teams to develop a semester-long project where they put all of the theoretical and practical knowledge they've learned in the major into creating a web or mobile application. And I really emphasize preparing my students for their professional future as a software developer. So I teach them about and have them practice giving presentations and public speaking, writing, learning how to collaborate and interact with other people. So it's not just about the technical programming skills, which they all have, but all those other skills that they'll need when they go into the workforce. I really emphasize professional ethics as well. I think it's very important to understand that as people going out to create software, when you create software, everything you do impacts other people. And whether you're creating a single button on a website or you're creating the next big application that's a social media app or whatever it might be, what you do is going to impact others, and you have to think about those decisions along the way. The other class I teach is Introduction to Robotics. This is an introductory course for students at any level to really get an understanding of how robots work. And in that class, I teach really the fundamentals of robotics from the hardware side. What are the physical attributes of robots that enable them to move around and behave in certain ways? We also talk about artificial intelligence. How do we use AI systems and models to control our robots, right? So that they can do the things we want them to do. We talk about how robots and humans interact with one another. And we also dive into responsible robotics and roboethics. How should robots be used, and where is it appropriate or inappropriate to deploy them? Great question. So uh, let me think for a second. Um, so it took me a while to figure out that this was the topic that I really was interested in, I was passionate about. I didn't start out in computer science. I actually started out studying economics and finance. I thought I was going to go into kind of a business field, and turns out that wasn't for me. And I kind of recentered myself and thought, what am I really interested in? What am I passionate about? And it was really understanding how data works. How do we use data to understand things about the world? And how do we use data to maybe solve difficult problems? And that's what ultimately led me to working in AI, working in robotics, because these are systems and tools we can use to solve these really difficult, important problems. Along the way, I've also learned the importance of uh, ethical uses of this technology, how it impacts underserved and marginalized communities. So I've become involved in an organization called Queer in Robotics. I helped found this organization for queer people, queer researchers who are interested in expanding who is robotics for, who is it built by, and building this community and solidarity among queer researchers who are often also marginalized within the research community. And so putting these passions together, right? How do we solve difficult problems? How do we solve interesting real world societal problems? And how do we build these systems in a way that's inclusive and ethical? I think I bring all of that into my classroom and into my research. Did you know how robots move through the world? It's not so straightforward. You may think a robot is intelligent, that it can decide what it wants to do and just get there and find its way around. In fact, robots are a lot more difficult. They are only able to do what they're told to do. And we write algorithms using AI systems to hopefully teach them how to behave in the real world. I'm sure you've come across a Roomba, maybe you own one, and if you've ever watched your Roomba navigate around your home, it doesn't seem very intelligent. It just kind of bumps into a wall, turns, keeps going, and it keeps randomly bumping around until it hopefully has vacuumed everywhere in your house. Well, can we develop robots that are more intelligent, that maybe think about where they're going, not bump into things, and maybe are easier to interact with, to work with, to solve difficult problems. And so robots don't come out of the box having some kind of knowledge or understanding of the world. We have to teach them. We give them a lot of data, we show them a lot of different things about the world, but we also have to give them the capability of understanding. What is it that things they're seeing? How do they put that information together to make decisions? And so that is how we might think about making robots that more intelligently navigate the world. Hunter is an amazing place to be. It is such a vibrant, wonderful community, and that's really because of the people. The people that are here make it such a welcoming place, from your professors to the staff to all of the other people, the students that are here. It really, that diversity of perspectives, of backgrounds, of interests, make every classroom, make every interaction new and different and interesting. I personally love it because I get to interact with students from all backgrounds in my classes, from first generation students who are the first in their family to go to college, and the hopes and dreams of their family are riding on their backs, to students who are so passionate about my research, about AI or robotics, who just want to take it and change the world. I love that. I love being able to work with all these different students and to hopefully pass that knowledge on to the next generation. I think that's what's amazing about Hunter. So one of the biggest challenges in computer science and really in STEM fields is making sure we have a diverse set of people that are creating the next generation of systems. We find over and over again that when you don't have that diversity, that inclusive approach to the community that creates these systems, that you don't contend with the bias that ends up permeating those things that you create. And so it is on us as educators to really think about how do we bring in a wide variety of people into the process of creating technology, and to empower people to feel like they have a stake and they have the ability to be involved. And so I really felt so passionately about this because I didn't really have that experience when I was going through grad school. I really felt this separation between my personal identity as a queer person and my professional identity as someone doing research in AI and robotics. It felt very separated. I had one life here, another life there, and it never felt like I could find this intersection between them until I really found this professional organization called Queer in AI, which brought these two worlds together. It really thought about how do we bring more queer people into AI? How do we promote it from all the way in high school and undergraduate students, all the way up to professors and professionals in industry, so that we're making sure we're including these voices in the development of these systems? And why is it important, right? If you think about large language models, are we making sure that they use inclusive language? Do they use the appropriate pronouns for people? If we think about generative image models, what are the kinds of stereotypes they're conveying about queer people? How are we making sure that we're building in safeguards to protect people's identities? And so these are the questions that, if queer people are not in the room, are being ignored. And so we want to make sure when we build these systems that we are advocating on behalf of queer people and that we are promoting and uplifting the next generation of students to go into the field as well.